Hey guys, welcome back. Now let's have a look over a new ADC, that's analog to digital converter, and it is MCP3425. And to gain more knowledge about this sensor, let's visit the website, that is controleverything.com, and here we have to search on for this sensor. As you can notice on my screen, it's MCP3425, and let's see what we got for this ADC. And as we see, it's a 16-bit one channel ADC, and these are some more features of this ADC, as you can notice on my screen. And this here is the section from where you can buy or add to cart. Furthermore, I will be interfacing the ADC MCP3425 with the Raspberry Pi, and a Python code is required for that. And let's go to resource tab, and here comes the Python code sample. You can get your hands for this code as zip file right from this website, and you can get your code from github.com also, and the repository there is Control Everything Community. Now let's have a look over the hardware connections we need to put up together, and let's see how do we get that. Well, in the hardware setup for the connections, what do we require is this Raspberry Pi, which you are able to see on my screen, and these are the GPIO pins of the Raspberry Pi. Next, we require an I2C Shield, which you can see, and it's available on the website controleverything.com. The real reason we are using this shield is to make easier connections with other I2C devices. So for that, gently place the I2C Shield over the GPIO pins of the Raspberry Pi and make a connection. Next, we need to power up our Raspberry Pi, and for that we require a micro USB cable just like that, and gently insert it over here, the power jack. And for the internet connection, there are two options. First of all, this here is an Ethernet cable or a LAN cable. Now gently insert it over this Ethernet jack, and you are done with the connections part. Now for the other internet connection, we can also have a adapter, a wireless nano USB adapter, just like that, and you can have on the USB port. Next, we require our analog to digital converter, that is MCP3425, and this here is a connecting cable. Now make the connection among the ADC and the cable, and make sure that the brown wire of the cable should be connected to the ground terminal of the analog to digital converter, and similarly to the ground of I2C Shield. Now we are done with all the connections for this hardware. Now let's have a look over the code. Let's have a look over the interfacing part, and for that we have to log into github.com, and then we have to search on for the repository, that is Control Everything Community, which you see. And then proceeding further, we have the ADC, that is MCP3425, and after that we have the Python code. But let's have a look over the instructions part. For the Python code, we have to download and install SMBus library on the Raspberry Pi, and the steps to install bus are here on this very link. Let's open up this link, and you can see yourself how to install, what are the procedures and the instructions you need to follow through. After getting that, we have to download the code onto the Raspberry Pi, and we have to run the code, and this is the command to run the code. Now getting back to the Python code, as you notice onto my screen, it's a .py extension file, and in the first thing you notice in the code is import of SMBus and time libraries. Then we have the address of the sensor, that is defined as 0x68. And in the writing section part, we have send configuration command, and it's 0x10 for continuous conversion mode 12-bit resolution, and the writing command is here. After getting that, we have to read the data back from the register, that is 0x00, and we are reading 2 bytes of the data for that. And here comes the conversion of the data, and the formulas, the procedure we have followed is given in the instructions for the data sheet for ADC, that is MCP3425. At the very end of our code, we have the output data to be displayed onto the screen, which is exactly the digital value of analog input. So this is how the code is. Now let's have a look over how it works. Now let's have a look over the working part, and in this thing we need to copy the entire Python code, and after that we need to connect to Raspberry Pi via internet, and here we have to create a new file, as you are able to see on my screen. .py will be the extension, and we have to paste the entire code here, and then we have to save it, and then this is the command, as you are able to see on my screen, and this is the command to run. And when I run it, we have the digital value of analog input, which you are able to see on my screen. It's almost 0, which means it's constant. which means either the ends are connected to each other, are grounded, or nothing is connected across the two ends. But instead, when I try to connect a AA battery of 1.5 volt across the two ends of the terminal for the sensor and I run the command, we have the digital value of analog input and it's 1033. It's almost constant because the standard voltage is flowing across the two ends, and it means the sensor works in a way which we desire. And now what do we want is to have a look over the applications and some of the benefits regarding this sensor. The MCP3425 is a single channel low noise, high accuracy analog to digital converter with differential inputs and up to 16-bit of resolution. The onboard precision 2.048 volt reference voltage enables an input range of plus minus 2.048 voltage differential. The device uses a 2-wire I2C compatible serial interface and operates from a single 2.7 volt to 5.5 volt power supply. The MCP3425 device can be used for various high accuracy analog to digital data conversion applications like portable instrumentation, base scales and fuel gates, temperature sensing with RTD, thermistor and thermocouple, and bridge sensing for pressure, strain and force. Well, you can have this sensor and you can purchase it from controleverything.com and you can get the code from resource tab. From this site, you can download the code as zip file. Also, you can get the code from github.com and the repository there is Control Everything Community. In the end, I would like to make it clear that if you have any doubts regarding any part of this sensor or video, you can have your queries on controleverything.com and you can post your comments on the community page on this website. For articles and blogs, you can have a look over on instructables.com. And to subscribe more video tutorials like this, you can have a look over our YouTube channel. In the end, I hope you enjoyed this video and had a good one yourself. Thanks a lot for watching.